AND gate gives a high output signal only if all input signals are high. For all other input signal combinations, the output signal will always be low. And now that is all. It is true, but this is absolutely the wrong way of understanding of logic gates. Look to the end and you will realize that this is a slightly bigger story that involves knowing the operation of electronic components. If you understand the essence of digital electronics, it is easy to design any smart electronic circuit. So let's start over. We first need to understand what logic high is. To make it easier to understand, we will work with concrete values. The voltage VCC will be the standard 5 volts, but in practice it is often a higher or lower voltage to which we need to adjust the logic circuit. Then we will mark the output. And finally we can understand why logic low is low, and logic high is high. According to standard values, logic low is any voltage less than or equal to a voltage of 0.8 volts. This is due to the voltage at which the positively polarized silicon diode conducts maximum current. That voltage is 0.7 volts or even lower. 0.8 volts gives us a guarantee that the output will always be logic low if the diode conducts current. On the other hand, the entire voltage range from 2 volts to the supply voltage VCC represents the high output. By measuring the output voltage level we can determine the output state, high or low. There is also a third area, and that is the forbidden area. This means that any voltage between 0.8 and 2 volts is not usable and as such represents nothing. However, it can cause malfunctions, and therefore this area is not used in digital electronics. Now we can go back to AND gate. Each input signal can be high or low, and since we have 2 input signals we will have a total of 4 combinations. In the first combination both input signals are low. This means that both diodes will be positively polarized and current will flow through them. As already mentioned, the voltage in this case will be 0.7 volts, which means the output will be low. In the next case the input signal A is high, and B is low. Due to the same potential on diode A, it is inactive. Diode B is positively polarized and current flows through it, which results in a voltage of 0.7 volts at the output, or low again. In the third case the input signal A is low, and B is high. Now the situation is reversed. Diode B is inactive due to the same potential at the cathode and anode, while diode A is positively polarized and current flows through it. As a result we again have 0.7 volts, which means low. Finally, in the fourth case, the inputs A and B are high, and therefore both diodes are inactive. Current has nowhere to flow except to the output. The output signal will be 5 volts in our case, or the amount of supply voltage VCC. Such a high voltage can only be high. So, all input signals must be high for the output signal to be high. For all other combinations, the output signal will always be low. Here we explained logic and gate with only 2 input signals. However, if you need more inputs, simply add more diodes. The mode of operation is exactly the same. In digital electronics, symbols are always used for logic gates. The symbols are different according to DIN, ANSI, and IEC standards. This is because logic circuits are used mainly as part of a larger circuit. Then we are mostly only interested in input and output signals without supply voltage for each individual circuit. Let's see the application of these logical gates. Sometimes you all run out of paper in the printer or toner, and without that the printer stops working. Of course, each printer has many more parameters that it monitors, and based on them it makes decisions whether it is ready to print or not. In this simplified version, We will analyze these two most common ones. It's simple. If paper or toner or both are missing, the printer does not print. We can also compare this logic gate to the switches in the series, which means that only if both are on, printing is possible. We can also give an example of a doors in a subway. You know that the train cannot leave if all the doors are not closed. Each door has a built-in switch that sends information when the door is closed. Only then is it possible to start the train. There are countless examples where these logical gates are applied. But when applying logic gates, you need to be careful how to connect them properly. The first rule, and perhaps most important, never, but never, connect two or more outputs directly to the same point. This will certainly cause a short circuit and probably destroy the chip. A short circuit and destruction occurs at a time when the two outputs are in different states. One is high, and the other low, in other words, a recipe for disaster. And be happy if that is the only damage. Often a destroyed chip causes damage to other components which can be much more expensive. So it is better to be careful. The second rule relates to the proper use of chip. Follow the manufacturer's instructions for use and pay attention to parameters such as maximum input and output voltage, maximum and minimum supply voltage, input and output current, frequency, and so on. And the last rule, it is allowed to connect the output of the first logic gate to one or more inputs of other logic gates or even to its own input. It should be noted that there are different versions of these logic gates, and it is up to you to choose the type that will give you the best performance with a good price-quality ratio. The most common are diode logic, diode transistor logic or DTL, direct coupled transistor logic or DCTL, transistor logic or TTL, NMOS logic, complementary MOS or CMOS, and so on. If you like this video, please subscribe, comment, suggest, and don't miss many more interesting upcoming videos.